I would like to start this session with the amazing talk that is going to be given by Professor Emeritus Yoshiaki Ohkami from the Keio University in Japan. I strongly encourage everybody to read his biography online. I just want to mention a few comments about his experience. He worked at UCLA. He worked at NASA Marshall Research Center. He was the deputy director for the Space Station program and was the dean of postgraduate studies at Keio University, worked at Tokyo Institute of Technology. So with any further introduction, I give you Professor Yoshiaki Ohkami.
Thank you very much, Mr. Chairman, for your kind introduction. I am here as an advisor to Keio Alpha Hyperloop team, which is very, very enjoyable. And before I talk on this topic, I'd like to introduce Professor Taniguchi here. And he's a professor of the same, the SDM, System Design and Management of Keio University. Oh, thank you. In addition to this, he's a special advisor to Prime Minister Shinzo Abe's cabinet, and he has a very strong relation to political issues sometimes. And in addition, he was a former executive advisor to Central Japan Railroad Company, which is closely related to Shinkansen, that's a bullet train. So most, maybe 70% of the materials are taken from his file. I stole. Okay, next. First, I'd like to speak about the past and present situation of Shinkansen. Before that, Japan is very well developed in terms of railway network system. There are some natural reasons for that. The area, total area of Japan is a little bit smaller than the state of California. But here, 75% is inhabitable mountain. So still the population is just half of the United States. So you can imagine how densely packed in habitable areas. That's why we need a really good public transportation system. And maybe fortunately, not area-wide, just a linear, okay, because of the mountain. That's another way. So, in 50 years, bullet train system network has been developed very well from all the way northern part to the southern island, okay? And this part and that part is still under construction. That will be completed before soon. And you will see that these lines are almost on the coastline, okay? This is very important because all the other areas like this are mountains, so there's no way to construct the railway other than the coastline, like here. Especially this part is very important in Japan. Here is Tokyo, and you may know the Kyoto and Osaka. Number one place, number two, and here Nagoya, where the Toyota and Honda and other industries are located here. So this area is very important. And numbers down here, let me say here. This is the length of the railroad, almost 550 kilometers. And this number indicates the number of passengers counted by thousands in a day. you can see how many persons are just using the Shinkansen, this bullet train system. That's a very, very basic, the fundamental, the basis of the public transportation system. There should be enough traffic to support or to use this kind of things. Okay? That's very important thing. All the other numbers are the same. I'll skip this one. Next, that area from Tokyo to Osaka, the GDP is this $1 billion, you say it's there. Just 46% of Japan's total GDP. Huge. And that will compare to something like Australia and New Zealand, Italy, and so on. Very compatible. Only this area. So, for that reason, this area is very, very important and needs a very good transportation, very fast, exact, safe, and things like this. That's the very important, let's say, the user side requirement. And what about the Shinkansen of this importance? Tokyo, all the way Nagoya and Kyoto, Yokohama. This is 550 kilometers and in 153 minutes. So there's some faster train than this, but this is average. And this distance is very compared to the Kuala Lumpur, Singapore, London to Edinburgh, Washington, DC to Boston, and so on. Okay, you can figure out there. So, with this Shinkansen system, we have a very good result. 0 fatalities over 10 billion passengers. Nothing. 15 services per hour. So that means every 4 minutes it starts and arrives. Okay? Very important. And this is a kind of the Japanese specialty. Average delay per service is 15 seconds. That means if the train passes through at some particular point of station, that the time is counted. The error is within 15 seconds, including some exceptional the heavy snowfall, the train will delay, but it will be cancelled by many, many trains. And so this big number per day, passengers. Anyway. And right after the final train has ended, then before the first train comes in, starts, the Dr. Yellow will inspect the railroad completely with high-tech, high-end, the inspection, the instruments, and computers, and so on. This is the key element of this to ensure the service, the safety. However, when this project was started in 1950s, there's very strong debate against this. Hot debates when this was started in 50s. Conventional wisdom is an enemy of innovation. You can see some examples here. Okay, new system must use or be connected to the existing rails to minimize cost and maximize the network effect. Must be locomotive drawn to reduce the coach car noise and so on, as the Europeans do. Must run on embankment, given that Japan is an earthquake country. This kind of the very strong debate happened. But strong voice of support is something like this. Dedicated elevated tracks only for Shinkansen with no level crossing, and the separated tracks each for westbound and eastbound. And this is very important. No need to prepare for head-on collision. Sometimes this was counted, and as a result, coach becomes very heavy, very rigid. But if you remove the threatening of the head-on collision, the wagon can be made lighter and flexible. That's a very important point. Furthermore, special law prohibits a human from entering the tracks. Zero incident track record and system crash avoidance. This part is particularly important. Safety ensured by initial design, not afterwards. From the beginning, from the outset, we should consider the safety as a part of very important design factor. So this was it. And if the good service is summing up like this, Shinkansen is operated on dedicated high-speed track, no freight or other passenger train on this track. And full grade separation, no grade collapsing, as you can see here. And separating rigid way of maintenance from daily operations, as I mentioned about the Dr. Yellow. That's out of service the time interval. Only maybe 2 or 3 hours they do the whole checkout. Some aspect, this is the most important technology factor in the train control. And thanks to this system, there's no train collision or no overspeed derailments with ATC for 54 years. Nothing. So this is a very dependable system. This is for driver's compartment. And all operations and movements of train set, including those in station and maintenance, under full automatic control. So not only the train itself, but the control system itself is controlled by this system. So high reliability of ATC system is essential to realize high frequency operations. So don't think this is one of the subsystems of the total system. This is at most important, okay, to make a very safe transportation system. And from the beginning, it's almost 50 years has passed, and technology, of course, advanced. Weight reduced, acceleration increased, height decreased, and electric power consumption down by 32%. This is what's happening. And still, there are many, many innovations, not innovation, but modification to improve this number. And the debate I mentioned is this one. Typically, a locomotive hold but distributed traction. Okay, this is a European style, and this is the Shinkansen style. And anyway, this was selected. Okay, in this selection, there's many, many arguments which is better. Okay, but anyway, to accommodate a heavy locomotive, the infrastructure gets costly to build and maintain. This is one of the key factors. And benefits of distributed the traction system is all about this. And this one, renewable energy system can be realized, and the length of the consist and variability. The variability is one of the key factors for the not for cost point of view. And normally, Japanese system has no key person. You don't know who is the key person. But in this Shinkansen system, this is the exception of the Japanese system. The key person is this person, the Shima, Mr. Hideo Shima. He is the father of the Shinkansen. And has many experiences from the end of the, not the end, before the Pacific War age and right after the war and the space age. This locomotive is called D51, is a best seller of the locomotive in Japan. He was the chief designer for this. And of course, Shinkansen, he designed the Shinkansen and whole the infrastructure design, including where the tunnel should be, where the bridge should be, and things like this. All the infrastructure was designed by him. And after he retired, for some reason, he became the first head of National Space Development Agency. Now it's called the JAXA, but he was the key person to be successful in launching this first rocket. And he was inspired when he visited Europe, and he saw this fancy car. I don't know exactly what it is, but it's a Huygens Hamburger during his grand tour in Europe in '36. And he was a very logical person. And anyway, he decided to all the structure. So we should talk about the political-economic aspects, which is very important to establish any kind of infrastructure. The politics comes in, and the economical consideration should be always there. So what is the political economy? So this started in 1950s. So at that time, Japan was completely destroyed in the state of debris, and some factories, industries are just coming up. So we need funds, okay? And funding the World Bank at that time. The Shima, not Shima, but his boss is called the Sogo, asked the bank to provide some fund. And as a result, the World Bank delegation visited Japan, and there's a heavy discussion about the system, especially the distributed traction, DT, is experimental. So don't employ that, forget that one. It's too risky. For this review, Shima asked the delegate, what do you mean by experiment? Just look at the laboratory at the JNR, Japan Railroad. Okay? There's nothing experiment. Experiment is all over. Okay? Now the time is the phase of development. And he demonstrated many activities there. And as a result, bank approved this funding. However, the important thing is not only that money, because the money fund was about 7.5% of the total cost. But important thing, once the government gets the money, there is no way to cancel. That means government should spend money, put the money on that project until it's complete. That's a very good tactics to get the continuous money. So that's one lesson to construct, to initiate some innovative things. So lack factor is, as I mentioned, World Bank, and wartime legacy. This is very complex, but during the wartime, most of the good engineer was employed by military industry. So after the war, they lost their job, and they moved to two things. One is the automobile industry, and the second is the railroad. Maybe shipbuilding is a third. And dream car. We need some dream after the war. And especially Tokyo Olympic, the first Olympic in '64. And actually the Shinkansen system was completed in '63, 1 year before the Olympic. New York City is an example. It's called Shin Yokohama. It used to be this the country area. And it became something like this when the Shinkansen started. But now, one of the biggest cities in Japan, there's no fields, no rice fields at all. Needless to say, this system is a whole matters, okay? Not a piecewise, just a whole. And subsystem includes so and so. I don't touch upon this. But here, moral of workers and drivers. This is a key element. And the Shima, the father of the Shinkansen, always tells us that moral and, not moral, the safety and quality depends only on the workers, not the people up there, just workers and drivers. So for example, Shinkansen driver is a kind of prestigious position. So they are trained and trained and trained, and they are very good at this system. So, and near future, Maghreb, of course. And this was explained by the second keynote speaker, so I don't, speak about too much about this. But important thing, this is the existing Shinkansen, and Maghreb is in the mountain area. As I mentioned, all these areas is a mountain, and Mount Fuji is somewhere around here. Okay, that means this line is almost in tunnel. Why this tunnel-oriented system is employed? The reason is here. One is, of course, it's very fast. But another reason is we have to provide, we have to prepare for some very, very serious natural disaster. Because earthquake, tsunami, and eruption of volcanoes. Especially tsunami. There is a good chance to attack tsunami attacks this area. In 30 years, the probability is something like 80%. Because of you just look at the past record, it's quite probable. And the Shinkansen lands very close to coastline. So tsunami attacks here, 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 maybe here. Completely destroyed. So it will take many, many years to restore that. So we have to prepare for that. This area is free from the tsunami at all. And second thing is the eruption of volcano. Mount Fuji is also a volcano, and so are many, many mountains, such mountains. So if very strong volcano, happened, the eruption happened, then everything is covered with ashes. So there's no way for transportation or communication. So this is a good, very good provision against these things. So mountain. Maybe 70 or 80% of the tunnel. So what about the innovation of Maghreb? That was completely explained by the second keynote speakers. But in this case, the superconductor technology is one thing, which is different from Hyperloop, which utilizes the permanent magnet. And second is electric coils on the ground as compared to the simple aluminum plate on the ground. And this is a superconductivity. I don't touch upon this. And also levitation system uses this. And levitation of the guidance are also used the superconductivity. Superconductivity is used only for this, obtaining a very strong magnetic field. It's a common thing. And now the test vehicle is open to public in some area. And this is the inside the cabin, and here is the indication of this speed. Very short video. This is open to public, and if you ask the office, you can take a ride. So, here indicates the speed and the distance traveled. This was taken by one of the secretary in the SDM, and acceleration. You can feel this acceleration. Now it exceeds 300 kilometers per hour. All the way, it's increased. And this is a camera to take a look at the outside of the train, namely the tunnel. The train is passing through the tunnel, and going out and again another tunnel. And the speed is 400 or something, getting increasing. If when this reaches to 500 kilometers per hour, it becomes constant by control. Even if it can increase more. Here, okay, that's it. And then what next? Probably ground vehicle running at a speed of jetliner or faster might be a target if this linear Maghreb system is completed. And that's exactly what we are doing. Hyperloop. That's the next step. Thank you very much for your attention. Please. That. Yes, that's a very good question. When it comes into the tunnel and comes out tunnel, it's a kind of sonic boom type of thing. But by devising the nose, something very, very long and very curious shape, it will be solved technically. Although there is some noise or shock, but it can be accepted by the passengers. But it's still underway to improve that situation. Okay? Okay. Switch from what? Oh, that's our dream. If the superconductivity is realized where upper something like nitrogen, the liquid temperature, that would be a revolution. That's a great thing. The cost will be decreased sharply because we don't have to use the helium. Very good point. So we are really hoping for that kind of innovation. That's a real innovation, I guess. Thank you. Please. Okay. Thank you very much.